In this lecture, I'll define matter, and we'll take a closer look at some of the many different ways matter can be classified. Matter is any physical substance or object, anything that occupies space and has mass, which is also another way of saying that it has weight. So it needs to occupy space and have mass. So if something has a volume, which is another way of saying it takes up space, and you can weigh it, then that object is matter. Generally, matter can be perceived by one of your senses. Perhaps it has a taste or it has an odor. The food you eat, the water you drink, the air you breathe, the clothes you wear, the roof over your head, all of those things are composed of matter. As chemists, we know that all matter is composed of chemicals, and the smallest unit of a chemical is an atom. Atom comes from the Greek atomos, which means indivisible. So here's an example. Gold is an element, and here's a lovely gold coin. If you divide a gold coin into smaller and smaller pieces, perhaps with a little axe, then you would still have gold. You would just have 2 pieces of gold or 4 pieces of gold. Eventually, if you had a small enough axe, and we don't have one this small, but let's suppose that we do, just for the sake of argument, eventually you would have a single gold atom. If you divide that single atom, then the substance would no longer be gold. So the element gold has a single atom as the smallest unit that we can call gold, and if we divide that atom up, then we no longer have gold. Most elements are unstable and react to form molecules and compounds. There's only a few elements that are common in nature as independent single atoms, and those are called the inert gases or the noble gases. Examples of those are helium, neon, and argon. The known elements are all collected onto a chart called the periodic table, which is shown here. There's a link to a nicer, more up-to-date periodic table with the other course resources, so please go ahead and take a look at that. This particular periodic table shows both the names and the symbols of each element, as well as their atomic number and their average atomic mass. We'll continue to describe the organization of the periodic table and the types of information it contains in other lectures. For now, please just note that there are many different types of atoms, and note that each type of atom has a symbol, which is either 1 or 2 letters. Atoms can combine together in different ways. Some species exist as single atoms, like helium and neon, in nature. But most types of elements are too unstable to be by themselves as single atoms in nature, and they like to be together with other atoms. Atoms like to combine with other atoms to form molecules. So here's an example. There's a couple of different cases. We could have the case where 2 atoms of the same type of element combine to form a molecule. For example, the symbol N is for nitrogen, so if we just had the symbol N written, that would be a nitrogen atom, which is also an element. So the symbol N is an atom and an element. But nitrogen doesn't exist by itself in nature. It likes to pair up with another nitrogen atom to make a diatomic nitrogen molecule. A molecule is a combination of at least 2 atoms. Could be more, but there has to be at least 2. Since both of the atoms in this particular molecule are made of the same type of element, we still call it an element, even though there's more than 1 atom. The second case is when a molecule is comprised of 2 different types of atoms. For example, this molecule, dinitrogen monoxide, has 2 different types of elements. So it's a molecule because it has more than 1 atom, but we call a molecule that has more than 1 type of element a compound. So let's do some practice. Let's practice applying these words: atom, element, molecule, and compound. In each case, you'll see that there's two answers which are correct when we are applying these words to different examples. So for example, if I gave you the symbol Ag, that's silver if you look on the periodic table. I've just written Ag by itself, so I can assume that it's a single atom, and I also know that it's a pure element because there's not more than one type of element there. So I could classify this as an atom and an element. In contrast, let's look at water. Water is a combination of hydrogen and oxygen. Because there's more than one atom present, we would say water is a molecule. And because there's more than one type of atom present, there's both hydrogen and oxygen, we would say water is also a compound. So water is a molecule and a compound. Here's another example, C60, which is also known as a buckyball. Well, I see only one type of element, so I could say that this is the elemental form of carbon, but there's more than one atom present, so it's also a molecule. This one's a molecule and an element. Your turn. Now you can try to classify a couple of substances as atoms, elements, molecules, and compounds. Why don't you go ahead and try to do that for F2 and C9H8O4.